Okay, so the last section in chapter 6, we're going to be talking about triangle similarity by side, 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 and side, angle, side. The side, side, side theorem is on your theorem sheet, and it says if two corresponding side angle lengths are if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if we have corresponding proportional sides, then we have similar triangles. So the first thing we have 3 triangles here, and we want to see is either of these triangles similar to triangle ABC. So the way we're going to do that is we're going to check our corresponding sides, and I have these color-coded. So the red corresponds with the other red, green with green, blue with blue. So the first pair of corresponding sides would be, for the first 2 triangles, would be AB to DE. So that is 8 over 6, which reduces to 4 over 3. Now, if the other ratios reduce to 4 over 3 in those 2 triangles, then they are similar. So another pair would be 12 to 9, 12 to 9, and that also reduces to 4 over 3. And the last pair would be 16 over 12. And that reduces to 4/3 as well. So yes, those two are similar because of side, side, side. Triangle ABC is similar to triangle DEF because of the side, side, side theorem. All right, and then we're going to check triangle ABC with triangle GHJ. So we're going to not look at that middle triangle for just a few moments. And we're going to compare corresponding sides for triangle ABC with GHJ. And so AB corresponds to HG, so 8 over 8 reduces to 1. And then BC corresponds with JH, so that is 12 over 10, which does not equal 1. So these two are not similar triangles. So the first 2 triangles were similar, the first and the last were not. So the one that's similar to ABC was DEF. Find the value of x that makes triangle ABC similar to triangle DEF in this example. So what we want to do is we want to find 2 sides that are corresponding sides and see what the scale factor is by getting that ratio. So we can see that we know both of the sides for AB and DE, and they are corresponding. So we're going to take those 2 and get the scale factor. We might want to say that we're comparing my little triangle to my big because we want to keep our same things on the same part of the proportion. So little over big, 4 over 12 is 1/3. So my scale factor for these 2 triangles will be 1/3. So then you find something with an x in it so you can find the value of x. So this side right here has x minus 1, and it corresponds with this measure, 18. So if I'm doing little over big again, that would be x minus 1 corresponds to the side measure of 18, and set that equal to our scale factor. You could set that equal to 4 over 12, but since we already reduced the scale factor, it's a little bit simpler. Cross multiply. So I have 3 times x minus 1 equals 1 times 18 is 18. Then we distribute. 3x minus 3 equals 18. Add 3, so 3x equals 21. And so x equals 7. And then you can check it. So everything should still have the same scale factor. So 7 minus 1 is 6. So this will be 6 to 18. That reduces to 1/3. I can check this one down here. 7 plus 1 is 8 times 3 is 24. And 8 over 24 also reduces to 1/3. So x equals 7. Likewise, in this problem, we will also want to use a pair of corresponding sides that we know both the measures to find the scale factor. So since everything is oriented the same way for these 2 similar triangles, those 2 segments correspond with each other. So if I'm doing the little triangle over the big triangle again, I always just go left to right. So whichever one comes first, left to right, it's easier for me. 20 over 30 reduces to 2/3. So that's my scale factor. So then I find something with an x, and I can use x plus 6, and that corresponds with QR, which is the measure of 21. So if I'm doing little over big again, I will say x plus 6 over 21 equals the scale factor 2/3. Again, you could use 20 over 30 if you prefer. Cross multiply. 3 times x plus 6 equals 42. And then I'm going to distribute. 3x plus 18 equals 42. I subtract 18 on both sides. I'm getting 3x equals 24. Divide by 3 and x equals 8. Again, I can check it. 8 plus 6 is 14. 14 over 21 does reduce to 2/3. Down here, x minus 2 would be 6. 3 times 6 is 18. And then 12 over 18 also reduces to 2/3. So that was just me just checking my answer. All right, our next theorem, which is our last one on our theorem sheet, is the angle side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. So, if the included angles are congruent and the two sides that are on the outside of those angles are proportional, then we have similar triangles by the side angle side theorem. So for this one, if we notice angle F and angle A are equal measures, they're both 53 degrees. So those two angles are congruent. So now we just have to check corresponding sides to see if they are proportional. My first pair, I have 6 and 9. So 6 over 9 reduces to 2/3. And then my other pair, I have 10 feet and 15 feet. So 10 over 15 also reduces to 2/3. And since those are equal ratios, then we can say, yes, they're similar because of the side angle side theorem. Because the angle is between the two proportional sides. All right, know the concept summary on page 390. That is also on the back side of your theorem sheet. So that just pretty much summarizes all of angle similarity, side similarity, and side angle side. So make sure that's a good little tool for you to study for your test. Which method would you use to show that these triangles are similar? So if you look at this picture, around angle C, I have a pair of vertical angles here. So both of those angle C's will be congruent because they're vertical angles. So if I could show that my corresponding sides are proportional, then I would have triangle similarity. So the angles between the two pair of sides. So I would use side angle side. So just to make sure, I'm going to do that real quick. If I were to rotate that second triangle around, it would be this side corresponds to this side. Also, you can do it largest to biggest. So those are both the largest sides for those two angles, so they will correspond with each other. And then likewise, for the triangle on the left, it'll be 9 corresponds to the length of 15 on the right. And we should reduce those. 18 over 30, divide them both by 6, and you get 3 to 5. Divide both of these by 3, and you get 3 to 5 as well. So yes, they are similar because of the side angle side theorem. And this last one, we want to tell if these are similar. I don't know why that P is there. Ignore that. We want to see if these two triangles are similar. I don't have any angle measures and they're not connected in any way, so I would have to use side. So if you have 3, what I would do is I would pick the smallest in each triangle, and those will correspond with each other. The two that are the medium sizes of each segment will correspond with each other, and the two largest sides will correspond with each other. So 16 is the smallest side here. That will correspond with 12. So I'm going to do 16 over 12. And I'm going left over right for all of these. The ones in the middle will be 20 over 15. And the last ones will be 32 over 24. And if they all reduce to the same ratio, then those are similar by side. So this reduces to 4 over 3. Divide these by 5 and you get 4 over 3. And divide these by 8 and you get 4 over 3. So yes, they're similar because of the side theorem. And that is all of section 6.5. Have a wonderful day.